Hey guys, welcome back to the channel. I have another interesting video here. This time in a 2008 Mini Cooper DME. It's a N12 R56. This is for Ron Reinheimer. I hope that I'm saying your name correctly. He is from Wisconsin. He sent this DME. I'm going to try to get his information. Let me just get to my website. Make sure that I don't have all his information shown. I think that's going to be perfect. So I'm going to put him in the screen and I'm going to read it for you guys. So it says that he is trying to diagnose a DME 2008, as I just said. It has a crank no start condition and is throwing a few codes, mostly U codes, which are no communication, and appears to indicate that the lack of communication with the DME. He said he has done fairly extensive testing, and for what I can read, it did. It says that I can tell and measure the DME is getting all the proper signals to start, but it appears not to be responding, including not grounding the DME relay pin 28 to provide power to the engine fuse box. And then you can read the rest in there. He also said that has verified all these powers and grounds, and then I'm not sure about this 27. I think this is the signals to start, and I'm going to show you that in a second. And then the PTCAN signals, which are going to pin 40 and 52, can network communications in between modules internally on DME. So I got ISTA pulled up. I'm going to now pull this uh, to the maximum. Let me get out of here. So I start with, oops, let me get back to where I was. Okay, so vehicle information. So as you can see here, this is an N12 and it's an R56. So we got all the information correctly, and this is based on his VIN number, which the last 7 digits is TT59646. How I get the information? I own Mini Cooper, BMW. I use always original information, and if I found an error, I always triple check things with Identifix just to make sure with the color wire diagrams that information in here is correctly, because I have indeed find even on the original information errors, and that's not uncommon, so just get used to it, right? All right, so I go here, I click in vehicle management, then troubleshooting, and then component structure. Let me just click in something else just to get the, so again, vehicle management, troubleshooting, component structure, and then in there, if I go over to the tab of this, is because it's already selected, I just click in components and then control units. Again, if I close all this, components, control units, I already know this by memory. So I go out to A6000, which is the DME, and then you have the SSB are the wire diagrams. You can see connectors in here. Like if I click in here, it's just going to open an image of the DME connectors, and then this is a 3-plug connector computer. You have X600, it's X6, 3 zeros, and then a 4. This is the first connector, and pretty much what I'm working on, because this is where powers, the grounds, and communication, and the activation of that relay that I'm going to show you in a second that he's also describing is connected to. Then you have connector X60211 and X60212. These two are 53 pins, and this is a 32 pin. I am a master on Mini Cooper, so I can tell you that that is indeed all correctly. I always leave those covers and everything in here so he can see that this is indeed his computer. All right, so going back into the information, I should probably start a screen recording, but this is quick, so I am trying to do it as quick as possible, and also to show Ron I'm doing the test on his computer, and literally everything is good here. So I think the problem that he has might be in the car. So the connector, or sorry, not the connector, the pin that he's describing is this pin 28 right here, and this goes to this X6300 DME relay. Is the control side from the computer. The computer is going to control this, and then it's going to send power back to something else. I will have to look into the DME, sorry, not the DME, the actual pinouts on the fuse box to see what it is, but that's his concern. So I'm following his concern and testing everything. So what I end up doing, I put another wire here to pin 28, which is right here. So we got pin 29 and pin 28 before that. So this is the ground control going in through a test slide to power. And then I also put channel C on my oscilloscope to see what is that doing when I power up the DME, right? I have channels A and B on CAN network just to make sure the activity is correct. All right, so let me just show you on the file. I'm a little tired, been a long week, but everything is nice. So let me, again, I'm trying to cover as much as information. Sorry if I don't show you what I'm looking at right now, but I'm trying to cover his information as possible. Okay, connections that you need for this DME to talk on the bench. Remember, everything I'm showing right now here is for the bench. So powers and everything is in connector X604. Powers 5, 16, 18, and the wake up signal on pin 19. Grounds are 3 and 4. Remember, this is for me to make this computer talk. CAN network or PT CAN. Remember, PT CAN is for powertrain CAN network on Mini Coopers and BMW. And then fiber reference. I got also fiber reference on the other connectors, and that's what I put them in there. Um, these computer, if you're in the car, you don't need a terminating resistor because it's going through the gate. In here, you will have to put 120 ohm resistor. So I got in these two connectors, which is pin 40 and 52. Sorry, 40, yeah, pin 40 and 52. I got 120 ohm resistor, and that will make the computer work, and I can talk, and then I can test everything correctly. So I have the oscilloscope connected. Right now we have just in here battery voltage because again is what I have connected even though I'm in the other side of the test light. Even the test light is not on because it's not being, sorry, because it's not being grounded, but the power from the power supply is going through and I can see that here. So what I'm looking for is that green channel go down as soon as I turn the computer on, and it does. So as soon as I power this on, we can see the activation on that. We can see the activity of the CAN network immediately, and I mean the light is on, so it's a robust driver enough to power up a light like this. And we have fiber reference in there, so I'm going to connect to the scanner right now. His bin number, he gracefully put him on his cover right here. So we got TT59646. When we saw that information before that I pulled from ISTA, but let's see if the scanner reads it, right? 2008 Mini Cooper, TT59646, so everything is there. So this is not his problem. The no communication might be inside the network or something else. I did run see some little corrosion on the center connector, so I will ask you to focus in there because it might be something that I cannot see on, because I don't have the car, but I did see some corrosion, very slightly corrosion, but terminals fitment is very important. So make sure that you have, I would recommend you to get this product, Dioxide D5 is really good to clean connectors. It's really, really good. And then you can apply that to the connector and then just blow air. If it's heavy corrosion, you're going to have to probably remove the actual terminals from the connector and then clean it and then install or replace if it's necessary. All right, so we are here now. I'm going to manually select because we only have the DME, right? So let's go over to the DME. And since I don't have much connected for the test that I'm doing again, um, I'm just going to read the data stream, voltage supply, battery voltage, and battery terminal, and then I'm going to change the voltage. All I'm trying to see here is to make sure the scanner and through the CAN network can read the data that I'm changing right now, which is the battery voltage, and it's correct. So I can see that, and I can see the message. Let me just change that. You will see the message changes. You see that? That is the message change right there of me bringing the power up and down on the computer through the scanner. So that is the message right there. So and we can see the difference on the voltage. I can now go down because I'm in 20 milliseconds per division because I was trying to show this. If I slow this down and we can bring the trigger up to a level, we will be able to see the CAN network. And the CAN network is nice and clean, no problems. So the communication is perfect. We can stop this and then analyze whatever we want to analyze. But we can see that this is being pulled ground and then we have a very good communication. So Ron, again, this is a test on your computer. Your concerns and for what you describe are not in the computer. This is good. It's a working. It's a clean computer. Nothing wrong. No corrosion. I went ahead and I'm going to actually revisit it with my microscope more in depth after I finish this test and this video to make sure that it's nothing that I'm missing. But I hardly doubt it. And your concerns are prove wrong here. I mean, not that you did anything wrong, but not on the DME side. That's what I'm trying to say, because you might be having a problem on a wiring or something else that might be necessary for this computer to work properly in the car. You can do the same test. You can check these same signals that I am providing here, and this computer should respond the same way. No doubt about that. The only thing that I'm not seeing is if you have a corroded connector and it's shorting out something in here, because these are injectors and coils and some other outputs, and I can show you on the wire diagram. Let me go over to to ISTA again, because remember this is the body side, let's say. So this is powers and grounds and communication for the computer. We have in here, so you can see that again, 3, 4, and 53, as you mentioned in your notes, are perfectly. I don't need them all because they're all shared internally in the computer. So I can provide just one or two. It all depends on how many tests I'm doing and the amperage that is going to draw. I usually connect two grounds just to make sure that I have enough to test what I'm doing and not creating heat problem, because the most wires I put, the better ground that I'm providing, right? So same thing is in the car. And then all the powers, as you describe, are correct. We have 6, 18, and I provide these three, 6, 18, and 5, and then pin 19, which is the wake up signal, which is, a 5 volt reference, sorry, a 12 volts or battery voltage. And then the communications, as you also described, in pin 40 and 51, right? 52. All right, so let me close this one and then let's go over to the DME engine side. So when we go over to the DME and the engine side, now we got all these connectors in here. I can then click an overview. I can see connectors, components, or whatever, right? So, and then this will take me over to that. But also here, let me close the overview. Let me zoom in, because all I'm really want to do is now click on any of the connectors. And this is going to open the connector view. Nope, that's not what I want. I want to get the pinouts. So let me close this again in here. Right here. I don't need to go any further. They're right here. Okay, so we can see what is in connector X60004. Sometimes I said too many zeros, but pretty much powers and grounds and communications are all in here. And the next connector, which is again another 53 connector of, sorry, 53 pins. Sometimes I speak too fast and I have to slow down. So we got the Valtronic motor signals, we got the fuel tank bend valve, exhaust camshaft sensor. So sensors are in the next connector. And injectors, we can see we got the fuel injectors. And then the next small connector has also the Vanos solenoid valve and the intake and the exhaust. It has three of the injectors, and it has eccentric shaft, ignition coils. So one of these actuators or one of the sensors might be your problem. I will again focus in the middle connector, which is again the X60211, sorry, that's a 53, which is what I noticed, that corrosion. It's not really a heavy corrosion. Let me uh, try to get the camera close, and let me get a plastic pointer so you can see that here, and I can show you all what I'm talking about. Hopefully the camera can pick it up good, but yeah. So this pin right here, I clean it, and these pins in here, still you can see a little bit of a green in there, but the terminals are now clean. So that will be pin 17, so 17, 16, 15, and 14. What we got in 15 and let me see, 15 supply engine temperature sensor and signal for oxygen sensor. So 17, 16, 14, 17, 16, 15, 14. So yeah, supply for engine temperature sensor and signal for oxygen sensor before calorie converter. And then this other one is pin, let me see, 31, 2. So 32, it says signal engine temperature sensor. All right, so we have those two pins, 14 and 32 by casualty, right? Or I don't know how to even describe it. They're both going to the coolant temperature sensor. So I will look into that connector, make sure it's not coolant going from the temperature sensor back into the DME, because sometimes it happens in through the through the insulation on the wires, and then I have seen oil migrating like that. I never seen coolant, but I mean it's not the first or last time that something new can happen, right? But definitely I was able to see the slight corrosion right there. That's the only thing I can see. For the rest of your computer, your DME is working good, so I will be contacting you shortly. Sorry guys if I make this too long, but I think that this is interesting. I can show you what I can do here and also what you can do, because all these same tests that I'm doing here, you can do in your vehicle if you take the time and you isolate what you need to isolate. Like, because if I remove this pin and this pin, this computer should be able to talk. So I would tell Ron, remove this connector and this connector and try to see if it still powers and works. And then connect the other one, connect the other one. I mean, or again, check the connectors. That's what I usually do in the cars as well. I'm trying to give you as much as steps I can share with you. Again, classes are coming soon, and I will be probably starting the classes as how to become a real diagnostician from beginners. And I'm not talking about a beginner technician, I'm talking about a beginner diagnostician. It's a very big difference when you go, when you move from a mechanic instead, point of view that you replace parts and everything, but you come into working in electric part, it's a very big difference. It opens a new world and is very profitable. So I will be putting classes from beginner to medium to advanced, and those are coming shortly. And this is going to be focused solely pretty much in European vehicles, BMW. All right, so coming soon. Stay tuned. See you next time. Bye bye.